Right, good morning everybody and welcome. My name is Craig Story. I hope you can hear and see me on this webinar this morning. What I'd like to do is just take you through what we're going to be covering today very briefly, and a couple of things that you need to know. Firstly, it's going to last 1 hour. The presentation will take about sort of 45 minutes. But I want to leave some time at the end for you to ask any questions so I can work my way through them and answer those questions. If you don't mind, if you could use the chat function on Zoom just to ask your questions as you think of them as the webinar goes through, that'd be brilliant. And then what I'll do once I finish the actual formal part of the webinar, then I'll go through and answer as many of those questions as I can. And we'll finish about at 12 o'clock UK time. So welcome one and all to this webinar. And this is about choosing the right noise measurement equipment. My name's Craig Story. I'm a business development manager with Cirrus Research PLC. I've been with the company for over 10 years, primarily sales, consultancy, that sort of thing. So I've done many occupational noise assessments over the years. So it's not just theory, it's actual practice. And I've actually been into many different types of industries to help them with their noise issues. So let's have a look at what we're going to cover today. And hopefully you can see these slides flip through as we go. So we're going to look at occupational noise assessing primarily. And what we're aiming to do is to look at the different options you've got for complete a noise assessment. And in that, look at the different types of equipment, what sort of equipment is best to use in what circumstances. And we're going to ask a few basic questions as we go through. We're going to see, do we need to actually physically measure or not? And we'll have a little look at that. That's quite interesting. We're going to look at the actual regulations themselves, the control of noise at work regulations, because it's important to know why we're actually doing this work at all. Because if we didn't need to measure noise, who would do it? You need a reason to do it, and a very good reason at that. Then we're going to look at the equipment. What equipment is available in general? Now, obviously, because we're Cirrus Research, I'm going to be showing you Cirrus Research equipment. But obviously, we've been manufacturing this type of equipment for over 50 years. Other equipment is available, but I'm going to get at the principles of why or what type of equipment is best in what circumstances. So that's really what we're going to try to get out of today. We're also going to look at what equipment should be used where and why. So we'll really look at that in depth. Okay. So why, first of all, why do we need to use noise measurement equipment at all? Why are we measuring noise, as a matter of fact? Well, we're looking at, obviously, protecting our workforce. It's a health and safety issue. We know that if you expose people to too much noise over a long period of time, then they're going to suffer from, and what I've put on the slide here, not just noise-induced hearing loss, which is a common term used for a reduction in hearing capacity due to excessive noise exposure, but also there's many other different types of hearing issues that you can get, things like tinnitus, hyperacusis, lots of other things which you can look up. So that hearing can be damaged in a number of different ways, but primarily we're talking about damage to the measurement device in our heads, to put it in another way, the cochlea. This is the part that senses the different frequencies of the sounds, passes those electrical signals to the brain, and that part of the hearing system can be damaged by overexposure to noise. There's also, of course, sort of physical damage that can occur to our hearing, and that's basically because if you expose people to such a high noise level, a very high difference in sound pressure level over a short period of time, you can physically damage your hearing instantaneously. For example, the most common one that people know about is the bursting of your eardrum. And you know, if you're near an explosion or you're too close to shotgun or something like that going off, then you can damage your hearing. So we know that excessive exposure to noise does damage our hearing, but there's another reason which is becoming more prevalent these days, and more people are realizing that having your workforce in an environment that is noisy, for want of a better term, that can basically, if they're exposed to it, even though it might not be quite at the danger levels for damaging your hearing, can be quite a stressful exercise for people to be in. So it can make their bodies more stressful, and that can lead to other issues, not least them not being able to perform adequately in the jobs that they're doing. So there's many reasons, but we do need to measure noise in order to understand whether those people are being exposed to too much noise or not. Here's an example, just a quick table of the prevalence of one of those items that I mentioned, tinnitus, in different industries. There's construction workers, musicians, oil refinery workers, or whatever. So these are some test samples. It's an HSE table that was done a few years ago. So basically, depending on who you are and what these are, I guess, the extremes, but just to show you that there's quite a large percentage in some professions that actually have a very debilitating condition called tinnitus, primarily because they're overexposed to noise levels in the workplace. So it's a very important topic, and of course what we need to do is we need to work out whether our personnel are being exposed to too much noise, or are they safe. So I mentioned right at the beginning that we need to find out whether you've got an issue in your workplace or not. I remember going on an HSE course many years ago, and they mentioned, and of course I'm from a sound level meter manufacturer, and they mentioned, well, you don't necessarily need a sound level meter or another piece of equipment to measure the noise. You can do an initial test first. And I'm thinking, oh, cool, that's going to put us out of business, but it makes sense. And that is, you can, what we call a very quick noise survey. No equipment's needed. And this is the first step in working out whether you need, whether you've got an issue in your workplace. And this is taken directly from the Control of Noise at Work Regulations 2005. And basically, it's basically saying, look, you know, if you're stood apart at 1 meter from someone, and you can talk normally, then it's a little bit intrusive, the noise, then the noise level is probably, and this is very rule of thumb, 80 dB or less. You can be in that area for quite a few hours. The potential is your workers are not at risk, and everything's fine. If you have to shout at somebody to make yourself understood at about 2 meters away, then the probable noise level is around about 85 dB. It's that bit higher. It's putting people potentially at risk. And you're going to have to do a risk assessment if somebody is in this environment for any more than a couple of hours. And this is a rule of thumb. And looking at the third one on the list, if you have to shout to somebody to make yourself understood and you're only 1 meter away from each other, which is not far, then yes, you've got an issue. And if anybody is in that area for any length of time, then you need to do a risk assessment or a noise assessment to understand what the levels and the issues really are. So this is, it's not saying this is completely replacing actually measuring the sound, but if you were a company that wasn't sure whether you needed to hire or purchase some equipment to do your noise assessment, a risk assessment on your people, then this is a basic step that you can carry out first, which will enable you to basically say, yes, I've got a problem, I think I need to look at it more, or no, I don't, I'm fine. And the HSE will accept this as an initial sort of survey to understand whether you as a company have got an issue for your employees. Now, moving on from this, of course, let's have a little look at the Noise at Work regulations, just to give us a bit of background, because when we're talking about choosing a piece of equipment, we need to know what those regulations are telling us. And of course, when we're talking about equipment, this is only the first step, remember. in dealing with risk issues associated with noise. What we're trying to do is find out if we've got a problem or not, and if we do, how big is that problem? How much risk are we putting our employees under? So it's all based on the Noise at Work regulations from 2005. It replaced the original ones from 1989. And of course, as we've said in these sort of talks before, it's called the Control of Noise at Work regulations. And that's important because we're not just talking about measure with whatever equipment we've got and then stop. It's all about measuring and then doing something about it in the right way. And it's not just, of course, hearing protection. Right? Hearing protection, of course, as we all know, should be a last resort. Lots of requirements upon employers, obviously, and employees. And of course, this doesn't apply to members of the public because we're purely talking about workplace noise here. So, as I've just mentioned, the aim is to eliminate or to prevent exposure to noise at its source. That's the goal. Get rid of it. If you can get rid of it, what's causing the noise, this excessive sound, that's the best thing to do. In all health and safety things, there's obviously a hierarchy of controls. So we're talking about assessing the risks from your employees, take action to reduce the noise exposure that produces those risks. And then if you can't do that, basically you're relying then on hearing protection to protect your workers. And that's where measurement comes in again, of course, because what sort of hearing protection do you need to give your employees? Well, the only way to know whether it's the right hearing protection or not is to use the right tool to actually do the measurement of the noise. Because too often we see companies who want to do the best for their employees, and what they're doing is they're buying the best, the heaviest, the most expensive, the greatest rated hearing protection they can purchase. And of course, that's not always the best thing to do. You can put people in more physical danger by getting hearing protection that's overrated than by getting the right hearing protection. Nobody has ever died, as far as I'm aware, of under protection from noise. You know, you put some hearing protection in, it's not enough, but it's not going to kill you. It'll dampen the noise a bit, but not enough. If you overprotect people, then they're at risk from missing vital instructions, safety alarms, they walk out from behind a vehicle, don't hear the car coming, that sort of thing. So people do physically die every year from overprotection with hearing products. So getting the right tool then to get the right value of noise that they're being exposed to in those particular circumstances, and therefore you can get the right hearing protection, is a very important thing to do. And as an employer, of course, you've got to make sure that those legal limits on noise exposure are not exceeded. How do we do that? Well, we need to know what they're exposed to and how you're going to bring those levels down. And keeping those employees informed with information, instruction, training, and all of that good stuff is vital. Because you've done all of this good work, you've got the right equipment, you've done your measurements, you've selected the hearing protection, you need to make sure your workforce is on board with all of this to make sure they understand why they need to wear it, where they need to wear it, and not just wearing it, but wearing it correctly and keeping it in the right condition so it is effective. Because hearing protection that is badly treated, is not worn correctly, you might as well not bother. You know, it's got to be worn properly. And lastly on this slide, carrying out health surveillance on your personnel where you deem that there is a risk for those people. And most good companies do that, audiometry, that sort of thing. So those are the regulations. And we've mentioned that we need to measure and we need to know whether people are at risk. So let's have a look at what we call the exposure values that are in those regulations, because this is the key thing. So we've got two key ones. There are actually three, but I'm not going to. We've only got a limited amount of time today, so I'm just going to focus on sort of two levels: the lower exposure action values and the upper exposure action values. And the key numbers that are in the regulations that you need to be aware of are two things. We're looking at a daily value, potentially weekly, but generally speaking, daily value an exposure of 80 decibels. And that is and the average, basically think about it as the average noise level somebody is exposed to during their working day. So if the value of noise, their average noise level that's any person is exposed to is less than 80 decibels on average, then they're deemed to be not at risk. Okay, so people sitting in offices and etc., not a problem. But we're looking for a second thing here. We're also looking for what's called the peak sound pressure level. Okay, and I mentioned right at the beginning that there's a couple of different ways we can damage our hearing. One is high exposure levels over long periods of time. And the second is if you've got instantaneous, very high noise levels, which could be over a very short period of time. If they're high enough, they can damage your hearing as well. So we're looking at two things within the regulations. We're looking at somebody's exposure over a working day. And we call this the LEPD, or daily personal exposure. I didn't invent the names, but of the nomenclature there, but that's the way it is. The daily personal exposure of 80 decibels. And then we're looking for the peak sound pressure. That means over their working day, what was the highest sound level that they were exposed to? And there are two levels here. And there's a big difference between them. So 80 decibels is the average. Anything below that, not at risk. Excellent. And the peak sound pressure level is 135 decibels. That's pretty high. And you'll notice, those of you who know a lot about this, one has got brackets A, which is the daily exposure value, and the other one is a brackets C, close brackets, which is the peak sound pressure level. So we're looking at actually two different ways of measuring that. The A stands for A weighting. So when we're looking at somebody's average over a working day, what we're really doing is actually getting those decibel numbers in our equipment and converting them to a level at which humans actually hear. So we don't hear all the sound that's out there, but a piece of noise measurement equipment does, because it's designed, it's a scientific instrument basically, but humans hearing isn't quite like that. So it's adjusted to the way we hear, and that we call that A weighting. But the peak sound pressure level, because it's so high, and we're looking at high numbers, we can use a different weighting, which doesn't sort of adjust it quite as much, and that's called C weighting. So any equipment that you have needs to be able to give you, in some way, shape or form, your average noise level, worked out as a daily value exposure, which is A weighted, and also a peak sound pressure level, which is C weighted. So I've gone into a little bit of that explanation. So we've got the lower exposure value, anything below that, not a problem. And then we've got this upper exposure value. And those two numbers are a little bit different. So the daily average is 85 decibels, A weighted, and the peak sound pressure level can be like a little bit higher, 137. So what you're looking at is if somebody is above those values, right, then they are definitely at risk, and we need to be bringing those levels down. But the only way to do anything about it, and that's obviously not the reason for this particular chat today, but you need to know what those levels are to decide whether they are below 80, so they're not at risk, and you can say, great, not a problem, we're fine, or they're above 85 and 137, which means they are potentially at risk, and therefore, if they are at risk, we need to do something about it. And then there's this bit in the middle. If it's between 80 and 85, or 100, it's around about 136, 135, 136 decibels for the peak. That's where people are what's called potentially at risk. And that gets a little bit more complicated, but still, we still need to look at that and do things for people. So those are sort of limits that we're working to. These are in the regulations. So we need something that's going to give us that information. So this is just summarizing it. So below 80, they're not at risk. Between 80 and 85, they're potentially at risk. So the yellow, I sort of color-coded this a little bit. And then if they're above 85 or peak value 137, then we've got a problem and we need to deal with it pretty quickly. So just to summarize that. So we're talking numbers here, and therefore we need some equipment that's going to give us numbers. Next slide, sort of typical values you can see here. So We know we're on an average noise level, we're talking 80, then 85 and above, but you can see there, I hope that's coming through clearly, that, you know, a lot of tools that people use, you know, chainsaws, drills, things like that, are quite above those sort of levels. But the key is that what we're looking at here is somebody's average noise level over a working day. And the other thing, which I haven't got on the slide here, but that you also need to be aware of, is that the length of time that people work is also important. So those levels that are in the regulations are for an 8-hour working day. Not everybody works 8 hours. So everything's calculated back to 8 hours. So if you work longer than 8 hours, then you need to make sure that you're exposing them to less noise, because they're squeezing the amount of noise from, let's say, a 12-hour shift back into an 8-hour period to come up with this daily personal exposure level. So the longer people work over 8 hours, the less they can be exposed to. The shorter they work than 8 hours, potentially, the more they can be exposed to. And there's various tools for doing these calculations. So you've got to be very wary of, yes, having the tool that does the right numbers for you, getting the data, but also how long people work. So that's very important. So what do we need? We need a way of getting the exposure that people, the daily personal exposure, and these peak values. So any measurement equipment that you've got must have, in my view, these two things here. Something called LAQT. Now, I'm sort of putting numbers in there, but basically what that is the average noise level over a period of time, which is A-weighted. So that's basically what your measurement equipment's doing. It's building up this average for you. And you might say, well, you know, why can't you just go in there and just sort of have a look to see what the level is, and that's what it's going to be. Sound noise isn't like that. It varies continuously as things are going on. It'll adjust itself. It'll be going up and down. If you're in a very high noise level environment, it may stay fairly steady, but that's pretty unusual. Normally, the noise levels are fluctuating. So you can't just look at a piece of instrumentation and get that feel for it. And those of you who know a little bit about decibels, of course, you'll understand that decibels are logarithmic. So if you had two numbers which are decibels, one said 70, the other one said 80, you'll say, well, the average is 75. It doesn't work like that because 80 decibels is 10 times bigger than 70. So it's, you know, you need to have a piece of equipment that's going to do those calculations for you. So you need something that will do an average for you on your equipment. And from that, you can then calculate somebody's daily personal exposure, because you'll know how long they're actually working, and it needs to be A-weighted. And then you've got the peak sound pressure level, again, C-weighted. So your equipment needs to have these two minimum things. So let's go on to the part we're really sort of interested in, and that's why, what sort of main pieces of equipment are there? So these are the two key things that we have: a sound level meter on the left and a noise dosimeter on the right. Lots of different variations in the way they look, but they're all doing the similar things and therefore specific jobs. They both, in general, have the same information within them. It's just how they're used is slightly different. Okay, and so let's have a little look at that. Let's have a look at a sound level meter then, first of all. So this is a handheld device. You hold it in your hand. I've actually got one here. You can see it, and it's a pretty small picture. So you hold it in your hand and you actually take physical measurement of the noise in the area that you're in. So a sound level meter will generally record all that information inside it and store it so you can look at it later on. Some of the simpler versions just have the numbers on the screen. But it's great for spot measurements. So what you're doing is you're measuring, you can measure people, so you can actually place it where people are, and you can measure spaces. So this is where people work. And of course, always be aware that when you're doing these sort of measurements, particularly with a handheld sound level meter, you need to be measuring where the people either physically are or they're going to be at the level at which they are. What I mean by that is the height generally. There's no point measuring a noise level in a room and you're measuring it 2 feet off the floor. Unless their normal activity, their normal work is 2 feet off the floor, you need to be measuring somewhere around where their head is. Because don't forget, we're interested in what these things, these ears, are actually receiving. So what does it do? It measures noise levels over time. Generally speaking, most of this equipment will give you a little bit of a history, so you get a trace of what's been happening second by second or minute by minute, something like that. But it will give you, if you've got the right piece of equipment, an average. And we call that type of meter an integrating sound level meter. So it'll do this. It's actually a logarithmic average. Don't want to sort of complicate it too much, but it'll give you an average. And what you're really doing then with the sound level meter is you're going out and taking samples in various areas with the sound level meter. So you're taking that instrument and you're going to measure the noise at workbench A, workbench C. You might measure it in a corridor. You might measure it in a general workspace where people are sat working, whatever. This is for use for sample measurements. So you don't typically run this for that long, but the length of time you actually take your measurement for is key, because remember, you're after an average. So once you've got your set of sample measurements, then you can actually use that data to calculate what somebody's exposure might be. So you might need multiple measurements. So it all depends on how you're going to attack the noise that you've got in your workplace, and every workplace is different, of course. So let's look at the other piece of kit, and then we could look at where both might be good or not so good. A personal dosimeter, called a noise dosimeter. We call ours a dose badge, other names for things out there. You can see in that little picture there on, that's somebody with a dosimeter on their shoulder. So what we're doing is, with all of this noise measurement, we're trying to measure what people's ears are experiencing. We need to measure what people are hearing, the noise level. That's really important. So a dosimeter is something which will sit on somebody's shoulder, typically somewhere close to the ear, and it can sit there all day long. So it's attached to the person, which is the important point. So it's measuring what that person is being exposed to, rather than you following them around with a sound level meter. So it's ideal for people who are mobile. They might be climbing up ladders, they might be riding along on forklift trucks, they might be cutting the grass on a ride-on lawnmower. You know, you can't run after them with a sound level meter and do that. It's just too dangerous and too impractical. So you need something that will sit with the person, and it'll typically measure for their whole working day or shift, depending how long that is. So at the end of that particular shift or day, your dosimeter, which has been sat on the shoulder, will have a full picture of what somebody has been exposed to noise-wise. Just word of warning, if somebody has you need to put it on the shoulder that is closest to the noise that they're generally experiencing. Sometimes it doesn't matter. Sometimes, if somebody's stood at an angle working on a piece of machinery all day long, put it on the shoulder that ends up being closer to it. Or even if you've got lots of them, put one on each, and they'll make quite an impression when they walk around with each of those on. But these noise dosimeters do the same things. They have the same numbers as the sound level meter. So you've got the LAEQT, air-weighted average noise level, brilliant, and it'll also give you the peak sound pressure reading as well. And the noise dosimeters will also calculate for you their daily personal exposure, typically. Because you've worn it for such a long time, then let's say, for example, somebody worn it for exactly 8 hours, then the average noise level that dosimeter has, call it 84 decibels, will be exactly the same as somebody's daily personal exposure, 84 decibels, because the average is 8 hours, and we want the daily personal exposure as an 8-hour value. So that's the way it works. So if somebody's worked more than 8 hours or less, the dosimeter will give you the daily personal exposure. So it's a really handy tool. A few other considerations then before we move on. You've got to ensure that any noise measurement equipment, whether it's a sound level meter or a dosimeter, meets the standards identified in the Control of Noise at Work regulations. So for a sound level meter, depending how old it is, it's got to meet one of these two standards that you see on the screen. It's got to be at least a class or a type 2 sound level meter. You get class 1 and class 2 sound level meters. And for noise at work, the specification is it's got to be at least a class 2. So class 2 is fine. As you would expect, class 1 is more expensive than class 2. What's the difference? Well, a class 1 sound level meter is more accurate across the whole wide range of frequencies that humans hear, where a class 2 is really is accurate in sort of this middle range. So it's normal sounds, you wouldn't really see much of a difference, but as long as you buy a class 2 or a type 2 sound level meter meeting these standards, you're meeting the regulations. For a noise decimeter, I've just spotted a spelling mistake there, a noise decimeter, that's something we're working on, I think, maybe not. That is, it's a different British standard, 61252, because they work slightly differently. They give you the same numbers, but it's a different standard because there isn't always a screen on them, etc., etc. There isn't a class or a type for decimeters, but as long as they meet that standard, so if you're buying something that needs to meet this standard, then you're meeting your obligations to the regulations. So I guess the whole point of what we're talking about, which tool is best, right? And there isn't an easy answer. There never is with these things, is there? So the rule of thumb generally is use a sound level meter when you need to know the noise level of a particular task, a process, or a specific area, right? Now, you could use a sound level meter for absolutely everything. But remember, if you've got employees that are out of your sight and they're not there, you need to sort of capture what they're actually being exposed to. So even though with a sound level meter, I've said we're looking at a particular task, process, or area, at the end of the day, you're still working that back to individual people, whether they're at risk or not. But it's just the way you're doing it. An example would be, that somebody sits at this workbench all day long doing a particular task. You can go in there and sample it with a sound level meter, and you'd sample it close to their ear with a sound level meter, that's fine. And you might go in there and take 10 samples in a day where different activities are ongoing. And from that information, you can then work out what their daily personal exposure is. You're still bringing it back to a person every time. For noise decimeters, you're looking to find the direct exposure of an employee by using a tool that attaches to them. And that's really useful where, it's impractical, it's not safe to actually follow people around with a sound level meter. Typically people, if they've got a large amount of work to do, will have a combination of both types of equipment, but you don't necessarily need it. It all depends on your circumstances. But if somebody says to you, well, how loud is that room? We're going to be putting people in there. There's a lot of machinery in there. Can they work in there safely? Well, yes, you could use a noise decimeter and sit somebody in there for all day or for a few hours. Or you could go in there with a sound level meter and just take a measurement for a period of time. So it really is dependent on what you want to do. But as long as they've got the basic values that you need, then you'll be fine. So how easy are these different types of equipment to use? So decimeters are great because once you've set them running, they don't need any manual intervention at all. They'll just sit on the shoulder, they'll run all day long, they'll collect the information all day long, and then you can download it at the end of the shift or the end of the working day. But the important thing about a decimeter is you do need to know what that person was actually doing. Really important, this, because you could say, right, put it on somebody, they go off and do a day's work around a factory or, whatever. They're off in the car or off in the van, they're doing this, that, and the other. They're installing kitchens, say, something like that. You get it back and you say, oh, your average noise level was 90 decibels, right? Your LEPD, it's told me it's 90 decibels. And then you think, well, okay, that's great. I know they're at risk, right? How am I going to fix this? And you'll see a trace, you'll see it in high noise levels, etc. But unless you know what they were doing at the particular times when those noise levels were high, how can you ever fix it? So even though it's on a person, you're generally not going to follow them around too much because that's the whole point of putting a decimeter on. but you need to have that information somehow, whether they fill in a form or indeed you actually just keep an eye on them for a whole shift. But you need to know that information with a dosimeter, because otherwise, how can you progress the information that you've got? With a sound level meter, you're physically there when the measurement's taken. So you've got it in your hand, you're pressing start, you're pressing stop, you're taking a measurement. You know what the level is instantly, you can see it. You can see if there's a problem or not, whether it's loud in here or whatever. But you've got to make a decision. The important thing about using a sound level meter to take a sample is you need to know how long to measure it for, right? And this is a very important part of taking a sample measurement of a sound level meter, because you could say, well, I'm going to stand here for 3 hours, right? But the way the sound level meters work, they will average the noise level. And the way averages generally work is the average sort of follows for the first few seconds what the noise level is actually doing. But as it's working its way through and it's getting more samples, that average will start to flatten out. So no matter what the noise is doing, even though second to second it's varying, that average will eventually become a constant value. And you've got to decide how long you need to do that measurement for with a sound level meter to get that consistent average noise level, and then you can move on. So you need to do a bit of thinking. You need to understand the process that you're actually measuring, or the area of the factory where you're measuring. Is it going to change? Is the noise level going to change every 10 minutes when a compressor kicks in? Oh, I need to make sure I'm here and measure that. Otherwise, you could walk away and miss it. So you need that bit of thinking. But generally speaking, most sound levels are pretty easy to use. You press start, you press stop, and you've got a piece of information in the middle. You've got the average. You've even got a little trace on a lot of them. You've got a lot of information you can use. So I've mentioned the two basic things, the air-weighted average sound level, LEQ, and I've also mentioned the C-weighted peak sound pressure level, very important, because they match up with the regulations. And this is the same for dosimeters and sound level meters. There are some other pieces of information that are also useful. One is the C-weighted average. Again, lots of letters here, LCEQ, T, which is the C-weighted average noise level, which will, generally speaking, be lower than the A-weighted. Not always, but generally speaking, higher than the A-weighted. Get that the right way around, Greg. It's going to be higher because it doesn't actually adjust it as much for the way humans actually hear. Why is that important? It's the same with the octave bands. That's another option you can get on equipment. That's where it's splitting up the noise level into about 10 to 16 individual frequency bands. So you can see whether you've got a lot of high noise, high frequency noise, or low frequency noise, or it's pretty flat or whatever. Why is that important to you? It's not absolutely necessary. It doesn't necessarily mean that you're going to not meet the regulations. It's useful for determining the correct level of hearing protection that you need in any given area. And it's important that you do, if there's a particular area of the factory or in a workshop or whatever that has got a high noise level and they need to wear hearing protection, you need to know what that level is, and you need a little bit more information about it to be able to decide on what's the right level of hearing protection to wear. It's not for this particular webinar today, but hearing protection and getting the right level is key, because as I mentioned earlier, if you over-egg it, you could put people in more danger than under protecting them. So these two other pieces of information are quite useful for doing that. There are automatic tools, there are HSC websites, there's things that use this information. You can compare the hearing protection you've already got and see, is it suitable for this area or not? So it's really useful to have this extra information to do it. There are some rule of thumb guides, which means you don't absolutely have to have this information. But if you want to do the best for your employees, having equipment that gives you this little bit of extra information just makes all the difference. Another thing I need to mention, because if you're buying equipment or leasing or renting equipment to do your work, you're never just going to have a sound level meter or a dosimeter. You're also going to have what's called a calibrator with it as well. So, the regulations state that you should be calibrating your equipment before you use it. So both handheld sound level meters and dosimeters need to be calibrated. And we call this field calibration. And you might think, well, I bought this equipment, why isn't it accurate all the time? And it's because we're in a world where we've got air pressure and different temperature ranges and things like this. You need to test to see if your system is fully accurate. Usually they'll make an automatic adjustment, so it's actually spot on before you actually start taking your readings. So having a calibrator with you is ideal. Again, there's a standard for the calibrators. Why wouldn't there be, that you need to have? It's just good practice to calibrate your instrumentation before you use it, so you know it's working and it's accurate. And then if you're out there all day, why not do a one in, you know, after 2-3 hours, just to check it again, and then definitely do one at the end of the day to make sure that everything looks good. Because when you get to the end of the day and you calibrate and it fails or it can't calibrate, something's happened. It might have been damaged in some way, or it's broken. Which measurements are good and which are bad? You may have to start again. So calibrating before and after, a really useful thing to do. Okay, we're sort of getting a little bit close to the end now. There are other options for equipment to supplement the assessments that you're actually doing, just to make you aware of other things that are out there. But what you need to do as people that are taking or looking into what the noise levels are that your employees are potentially at risk from, you need to look at a few different things. So you need to make sure that, you know, the noise levels aren't product specific, and if they are, do measurements on different days when those products are running. Variable workloads in the factory. You might be doing it when it's really quiet, and then it gets busier every September. Do it when it's at its worst case if you can. Entertainment noise, that varies really considerably, making sure that you take the different levels of shows and things into account. So if you are getting to that point, then you need to sample over multiple days. And always, I think, make sure you sample a selection of people doing similar roles. So if you have the equipment yourself, rather than getting consultants in, it's always an advantage to be able to do multiple measurements with multiple people, particularly with dosimeters on the shoulder. Then you can get a really good spread of what those individuals are being exposed to. One of the other things you can think about is what if noise levels change over a longer period of time? Can we monitor these workspaces over time? Should we be doing that? Is it necessary? Would it help? Potentially, yes. So if you've got something that you know what the noise levels are, you've done your assessment, you've used the right equipment, you've detailed who's at risk and who isn't, and you've got something in place to make their lives less noisy, and you've got hearing protection, etc., etc. But your business might be one where you're putting new equipment in all the time, or the noise levels, depending on what products go in the factory, through the factory, varies considerably. It might be worthwhile trying to log data over a longer period of time, rather than just doing your assessment every year, 2 years, or whenever something physically changes. So we can do that. It doesn't supersede risk assessments at all. But what it does do is it gives you extra information. So a couple of examples of this, you know, this is a more permanent solution where you can have a permanent noise monitor in some place in the workshop, just to understand where those noise levels are. They starting to rise? Are they falling? You know, do we jump up on days that you weren't expecting it? So then you can go back in and just reassess whether there is an issue or not for the employees, particularly if you think, well, we're sort of borderline, but we don't want to impose a mandatory hearing protection zone. But then you look at the data and you say, well, actually, well, we're way over now. Maybe we need to go in and relook at this. So there are situations where something like a permanent monitor, like I've got on the screen there, will do that. It's there to give you more information. It's there to enable you to make better decisions over the longer term. And then just a quick example, just to finish off, of things like noise activated warning signs, things like that, because a lot of areas are quiet until somebody turns a great big machine on in the corner, and then, you know, the whole place reverberates. Now, there should be a way of stopping that by, you know, there's things you can do, boxing it in and putting it somewhere else, blah, blah, blah. But you know, you can't always get to that point. So something like a noise activated warning sign could be a useful addition. They will light up when the noise level gets above a certain level, indicating for people, put your hearing protection on now because the noise levels have shot up. And some of these systems can do sort of basic data logging as well. So take a sample every 5 minutes, 10 minutes or something. So you've got some sort of a history. Not as detailed as some of the others, but at least you've got something. So there's different tools you can use, not just for the measurement, the sound level meters against the dosimeters, but also for putting something in after you've done that work to help with your sort of noise management program. So we're getting to, I said we'd leave some time at the end for some questions. So just to conclude then, what we've been talking about today for working out people's, or doing a noise assessment, is the two main tools that you've got, a sound level meter and a dosimeter. And to put it even simpler than what I've already done it, it's more about place against people. Now we're always interested in people, obviously, but there are ways to get at that information for the people or the group of people that you're looking at. So sound level meters are more about place, and dosimeters are directly attached to the person. So you've got 300 people working for you. You're not necessarily going to put a dosimeter on 300 people. And they're all working in the same sort of general area. So a sound level meter may do that task fine, but you may want to supplement it with putting a dosimeter on a few people's shoulders. So that's why, you know, both options might be required. It all depends on your circumstances. Each workplace is definitely unique and different. So it's not a one size fits all. And of course, what we're always doing with this is focusing on the risk to the individual, and whether their average noise level, their daily person exposure is basically getting above 80, and whether their peak noise level is getting above 135. If we're getting that from the information our tools give us, then we need to do something else. And of course, the assessment, this is what we've been talking about here, that's just the start, remember? That gives you the information to actually say, are people at risk or not? And if they are at risk, then that's where the process starts in basically mitigating that risk in all of the different ways that I alluded to, but obviously it's not part of today's talk. Now, if anybody's got any questions at all, or wondering whether they've got the right equipment or whatever, please contact us here at Cirrus Research. We'll give our best advice to you. If we can understand a little bit about your circumstances, we can just say what's right and what isn't. Like all manufacturers, there's a range of instrumentation. You don't have to go for the whole hog. There's things that can be that might be right for you that might not be right for somebody else. So it's always worth contacting us and then taking our advice on board, and then hopefully we can help you with that. So I'd basically like to thank you for listening today. But before we go, we've got about 10 minutes left. If anybody's got any questions, pop them on the chat now. I don't know whether you maybe heard me at the beginning. I've got a couple on here that I'll go through. If you've got any more, there's a little bit of time. We've got about 10 minutes to talk through any questions that come up. See somebody, Tim has put on, I mentioned right at the beginning that overprotection can be deadly, and somebody sent a link which is very helpful, thank you. When there's a railway accident, I don't know whether you saw it in the news, was partly attributed to overhearing protection. Hearing protection was over specified for the job that they were doing, so they didn't hear the train coming. I think just part of the incident, so that's very true. So it does happen on not a regular basis, but it does happen quite often. I've got somebody asking a question, Adam. It's slightly different to noise at work, but can a class 2 sound level meter be used reliably for environmental noise monitoring? I'd only thought these should be used principally for noise at work. Right, yeah, good question. This is the difference between class 2 and class 1 sound level meters. So the numbers that they give you in terms of the parameters, LEQs, peaks, maxes, I've not mentioned maxes and things like that, yeah, the meters will calculate them in the correct way, whether it's a class 2 or a class 1 meter. I would say this, if you were wanting to get environmental noise monitoring numbers, for example, environmental noise monitoring would be something like, I'm disturbing my neighbours, there's a house across the road, we're making too much noise in our factory, I want to measure the amount of noise that's leaving our factory, so I'll put a sound level meter out there, and then for a few hours, and I know what the level is that's leaving the factory. So that will give you an indication of what that noise level is. If you had to prove to the local council that you weren't making too much noise, or somebody served a noise abatement notice or something like on those lines, then I would always use a class 1 meter, because that's the best you can get, and it's less likely for people to actually argue against it. So that's that. Hopefully answers that question. Another question I've got here is, how do you identify erroneous peaks on dosimeters? For example, collars rubbing against the microphone. Good question. Dosimeters are notorious. As soon as you knock them, then they can register quite a high noise level. It's just because the microphone's really, really close to the body, and that will happen. So we have some dosimeters, and ours have a sort of a tamper detection system. So if somebody actually taps it or knocks it, then it'll detect that it's been moved. So you'll get a high noise level, but it'll also say it's been tampered with, and then you could ignore them. So that's one way of doing it. If you've got collars rubbing against the microphone continuously, adding to the noise, then yes, it's worth checking to see if it's fitted in the right place. The shoulder, right on top of the shoulder, close to the ear, isn't always the best place, depending on what clothing they're wearing. So make sure it's fitted securely, and that it's not being affected by other clothing. So it's always useful to do that. It's not always perfect. That's why it's sometimes useful, if you've got some dosimeters, put it on quite a few people, maybe do it over a couple of different days, just to sort of iron out some of those issues. But make sure, don't just leave them and never look at them. Keep an eye on them, because people, sometimes take them off. They're on the jacket, they take it off, sit down, forget to put it back in. So it's always just worth keeping an eye on it, making sure they've got it fitted in the right place. Somebody's asked, this is a different Adam, I wanted to check, did you say there are signs that can light up when excessive noise levels are occurring, prompting people to wear the appropriate defenders? Yes, that's correct, Adam. We call ours a sound sign. You can set an individual noise level on it, and it will light up when that noise level is breached. And that sign has 3 or 4 different pictures you can have on it, and that will prompt people, because it's the warning colours. It's blue and white. It'll warn people that they need to put their hearing protection on. So give us a call. Have a look on our website for sound signs, and you'll see that product. Another question from John. Could you use your dosimeter as a sound level meter, or do they read differently? They sort of read differently, but in a strange sort of way. So normally dosimeters, or let's take sound level meters first, they go down to 20 decibels, usually up to about 140 decibels, a big wide range, right? So you can use them in quieter areas and loud areas. Dosimeters only go usually down to maybe 60 decibels, up to 140. Because we're using it specifically for whether people are at risk from noise at work, we're not interested in anything less than 60 decibels or even 70 decibels, because that doesn't affect their overall average noise level over a shift. It doesn't matter. So that we can get away with that high level. That's why they're so small. We're able to keep them small. So, they'll give you the same readings. It also depends with a dosimeter. You should get very similar readings if you followed somebody around with a sound level meter and with a dosimeter, very similar readings. The average noise level, the peaks would be the same. So you could use it as a sound level meter, sort of, but you've just got to be very careful. Depending on where you put it, remember sound reflects off hard surfaces and things like this. So if you put it on a desk, it's going to read differently than you had it hold it in the air. If you can, use a sound level meter if you can. Another couple of quick questions. Right, so This is hi, if you have a split shift, can you combine 2 daily readings to get a full day figure? Or do you have to leave the dosimeter running and then you can discount the gap? Very good question, Matthew. So split shift, I'm guessing, is somebody that is working for, say, 4 hours, they go home, and then they'll come back and do another 4 hours. If you have the right dosimeter, then you could leave it running. And then with the software that comes with it, you can just take the 2 individual pieces and use that as your data and discount the part in between. But if it's on 2 different days, you know, the 2 reading on 2 different days, then I would sort of treat them as 2 individual daily figures. You know, you could average them together if you want. So it's up to you, really. You can leave a dosimeter running. The problem with dosimeters, if you leave it for too long a gap, then it might end up running out of battery. So, you know, always, if you can, stop the dosimeter running when they've finished their work, start it again when they recommence it. But if you have to leave it running while there's a period that nobody's at work, they've gone home or, you know, gone on an extended lunch or whatever, then there's usually software that will be able to do that piece of work for you. So you can work out what the level was before and the level was afterwards, and you can combine it. So that shouldn't be a problem. Where are we now? Another question from Brian. I'm a landlord. My tenants sometimes have problems with neighbours, and I want to instantly respond with appropriate recording equipment, etc. What is the best device for use for this? That's not really what we're talking about today, Brian. But there are tools available for that particular purpose. So generally speaking, for noise at work, we don't record the system, the audio, which is what you're talking about, but you can do that. So you could have a meter that's sort of the next level up, which will actually record the sound. Sometimes that's quite good. So you're doing a noise assessment and you say, right, I just want to get a recording of what that sounds like so you can listen back to it later on. But we do have equipment that will do that. And also we've got what we call noise nuisance recorders, which actually record the sound. And as I mentioned, we've got some permanent noise monitoring equipment as well that can give you text messages and emails and all that sort of stuff. So there's a wide range of equipment. Give us a call and we can have a look at that. But if it's personal, I think, you know, you can always sort of try the local council if it's an environmental health noise issue. They've got equipment that they can use to actually look into noise nuisance as well. So that's always another call you can make. Right, time for one more question then from Peter. Hi, how would you manage a person's exposure if they're walking past a machine that was above the upper action value? So how would you manage a person's exposure if they're walking past a machine that's above the upper action value? So first of all, you've got to understand what that person's exposure is. So if walking past that machine is part of their normal activity, let's say you could use a dosimeter, put it on there. They're doing all sorts of other jobs, and part of their job is walking past that machine. If you know when they were walking past that machine, you can look at the dosimeter data and see what the level was as they're walking past that machine. Or you could use a sound level meter to say, right, I'm going to measure where people are walking past this machine to see what that level is. And if that's really high, 90, 100 decibels, whatever it happens to be, you can then say, right, should I be exposing to my people, even if it's only for a very short period of time, to that sort of noise level, because they've got to walk past this way, I'm guessing. Then that's where you'd start to look at saying, right, how can I reduce the noise level of that particular machine to reduce people's exposure? Because it will reduce people's exposure. So you could also look to see if just walking past it once or twice a day is going to elevate their exposure, and then measure it. So get a measure of what that level is, because if it's really super high, remember this, if noise levels are above 100 decibels, you will only have minutes in that environment where the levels of 105 plus decibels before you've breached your exposure for the day. It doesn't matter what you do for the rest of the day. You can go and lie down in a quiet, dark room. Doesn't matter. You've only got a few minutes, literally a couple of minutes in a high noise level before you've blown your limit and you're at risk. So yeah, measure it always. Okay, I'd like to say thank you to everybody for participating. Some great questions. This is being recorded, so hopefully you'll be able to sort of listen back to it. I hope you found it useful, and then watch out for the next one we do, probably in the new year now. But thank you again, everybody. Bye-bye.